3.3, number 109. So from the examples I just brought, there could easily be a question on what is the order in which to apply the derivative rules. I will use this one, 109, to explain out how this is done. The general approach is the derivative moves, the derivative applies from outer operations to inner operations. Okay, that's a little vague. But again, I'll try to demonstrate with this problem what I mean. Okay. I mean the operations within the function that we're talking about. Okay. So f of x for 109 is 8x to the fourth plus 9x squared minus 1. A person will get a facility with this very quickly as they do more and more problems, and the explanation I'm about to give will seem more and more unnecessary as you develop a visual acuity for noticing how to apply the derivative properly. So here we're just taking the derivative, so f prime of x is, again, I'm using the tick mark notation because it's faster here. There, okay? So now, how does this tick mark apply in here? Well, what's the most outer operation happening in the 8x to the fourth plus 9x squared minus 1? The most outer operations happening are the pluses and minuses between the three terms. Those are the most outer things happening, okay? There's also products and powers, right? You have 8 times x to the fourth and 9 times x squared, and you have powers x to the fourth x squared. But those are happening in a more inner type of way, i.e., if you were to take a number and substitute it into this function, the first thing that would happen is you would apply the powers to that number. So the most inner operation is the power function. Secondarily, you would then multiply by these constant multiples 9 and 8 to those two powers. All right, so that's the next most inner thing. And then finally, you would add and subtract, so therefore that is the most outer thing happening. So therefore, the derivative will apply itself to the sum and difference first, and therefore the distribution of the sum difference rule happens first. Again, I'm writing the whole thing out. Once a person becomes very comfortable with this, they would not write out all the steps that I'm writing here. Matter of fact, the answer to this is so obvious. Once you work a few problems, you would never write all these steps. But just to show exactly what's happening. And that's first because the plus minus the most outer operations. Okay, we said the next most outer operation was the multiples 8 and 9, right? So that means the constant multiple rule is invoked, and now the derivative will, in a sense, move past the 8 and the 9, in a sense, skip over them. So you have 8 times the derivative of x to the fourth plus 9 times the derivative of x squared. And it's true, you could go ahead and apply this derivative. I'll save it off here for 1 second, even though we know it's 0 because this is the constant rule, not constant multiple. So now all you have left is to take the final derivatives. So the final derivatives to take are on the most inner thing happening, which is the powers. So that's the power rule. And then this one I just saved back. You could have done it in the last move. It doesn't matter. This would be 0, of course. So now you finally get 8 times 4x cubed, again, application of power rule, last in this case, because it is the most inner operation that was happening arithmetically back there. And 9 times 2x to the first, I don't need to write the first power though, minus 0. All right, now you just finish off by simplifying the derivative function you have now. So 8 times 4 is 32. X cubed plus 18x, and I don't need to write the 0. So there is our derivative function, and that is the order in which you apply the rules.